All right, so here we're doing chapter 4, section 3, triangle congruence by angle, side, angle, and angle, angle, side. Our learning objective is to prove two triangles congruent by using the angle, side, angle postulate and the angle, angle, side theorem. All right, so the 4-3 postulate is the angle, side, angle postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then we can say that the two triangles are congruent. Our other method is we show all three angles are congruent to the other three angles and all three sides are congruent to the other three sides. This is technically supposed to save us time and effort by just finding two angles and one side that's included in between the angles. So you guys see how the side is sandwiched in between the two angles. If I had side BC, it would not be angle, side, angle. It would be angle, angle, side. So explain how the angle, side, angle postulate is different from the side, angle, side. Please note, angle, side, angle has two what's? Two angles. Side, angle, side has two what's? Sides. Okay, that's the difference between the two. Or, as the book likes to say, explanations may vary. Please do not write that. The angle, side, angle postulate uses two angles and included side. The side, angle, side postulate uses two sides and an included angle. Let's see if we understand that topic. Take a look at these three triangles. Which two are congruent by angle, side, angle? I am automatically going to cross this one off the list. Because, and I have to erase this a little bit to show you, because this one has an angle, and the side is not in between those two angles. So he doesn't count. So, triangle HGO, or I would write that as HOG because it spells hog, is congruent to triangle ACT because HG is congruent to AC and congruent segments are included between two pairs of congruent angles. They have the angle, side, angle. All right, so name the triangles, list the vertices. So now we're going to take the same problem we did and break it down. So what I want to do is go over this information with you. List the vertices in corresponding order. List the vertex with one arc first and the vertex with two arcs second, and the third vertex last. So triangle GHO, triangle INF, and triangle C. All right, so angle G is congruent to angle I, which is also congruent to angle C. Angle H is congruent to angle N, which is congruent to angle A. HG is congruent to NI, which is congruent to AC. The congruent sides that are included between the congruent angles are this one here and that one there, which are called HG and AC. And then write a congruent statement, justify your reasoning. Triangle GHO is congruent to triangle CAT because they have two pairs of corresponding angles and a pair of included congruent sides. If you put answers may vary, you may not make it to see tomorrow. All right, so here is the information that we're given. Angle CAB is congruent to angle DAE. Side BA is congruent to side EA. Angle B and angle E are right angles. We need to prove that triangle ABC is congruent. So what we say is that angle B is congruent to angle E because all right angles are congruent. Side AB is congruent to side AE, and angle CAB is congruent to angle DAE. That information was given. So triangle ABC is congruent to triangle AED because of angle, side, angle. So theorem 4-2 is angle, angle, side. And it says, if two angles and a non-included angle, non-included side of one triangle are congruent to two angles in the corresponding non-included side of another angle, then two triangles are congruent. So the non-included congruent sides of ABC and EF are AC and DF. This gets a little bit trickier because they're going to start stacking shapes on top of each other. And what's the property where the two shapes are stuck together and we have to say one side is equal to itself? What's that property? It's like we used it yesterday where it kind of looks like RF is congruent to RF. What is that property? It's the reflexive property. So remember, we have to keep that in our back pocket. What's the other property that we got to keep with us? Keep it real tight at it. Vertical angles, because those kind of things come up. We learn them in the previous sections, but they keep coming up over and over and over again. Okay, so if you look at problem number 3. These MWR and WKR, those triangles share a common side. So when that happens, you take, we have our given information here. Angle M is congruent to angle K. WM is parallel to RK. And then we know that angles MWR, which is that one, is congruent to KRW, that one, because if lines are parallel, then alternate interior angles are congruent. Side WR is congruent to side WR, there's that reflexive property. And then triangle WMR is congruent to RKW because they have angle, angle, and a non-included side. Angle, angle, side. All right, so let's look at this question number 3 and go through that same process. We are given that angle S is congruent to angle Q, which he is over here. This is Q. And that RP, this line right here, bisects angle SRO. This whole guy here. We need to prove that the triangles are congruent, SRP and QRP. So we look at the information we have. We only, truly, right now, we only have that, we've got two angles are congruent. How are we going to get out another angle being congruent? How are we going to use this information to show that I got two more angles that are congruent to each other? What do you think, Thomas?
Since the PR bisects the SRQ, the angles on either side of the bisecting line are going to be congruent.
So we're going to say angle SRP is going to be congruent to angle PRQ. And what's our reason? So that's the definition of an angle bisector. An angle bisector creates two congruent angles. All right, so once we have that, we know that this angle is congruent to this angle. We can write it on our figure because we've stated it as a fact. All right, so what other piece of information do we need? We need a side because we want to do angle, angle, side. So I'm shooting for angle, angle, side. I want to show that PR is congruent to PR. Why can I say that? What property can I use to say that? As a reflexive. I also want to include this as in my given and this in my given. All right, so I've got an angle, and a side. I can say that triangle SRP is congruent to triangle QRP. And you guys double check that my letters are matching to their matchers in the other triangle. And we can say that because we have an angle, angle, side. All right, our triangle PAR congruent to SIR. And explain. So we are given that angle A is congruent to angle I. We are given that side PR is congruent to side RS. We can show which two angles are congruent. What theorem are we supposed to keep in our pocket and use for later? Reflexive and vertical angles. Do I have vertical angles here?
Yes.
R. They live right here. So angle PRA is congruent to angle SRI. By the vertical angles theorem. So I can say that triangle PAR is congruent to triangle SIR by the angle, angle, side.